Okay, number one, first of all, we do know it's a triangle because 7 plus 9 is bigger than 12. So now to figure out what type of triangle, we're going to compare the square of 12 with the sum of the two smaller sides. 144, this is 49, and 81. This adds up to 130. 144 is greater than 130, so this is an obtuse triangle. First of all, we need to know roughly what this is, and just putting it in a calculator, we see that it's about 8.6. So we do know it's a triangle because 8.6 plus 6 is bigger than 10. But this is the longest side, so I'm going to compare that side with the sum of the other two sides. This is 100. When we square this and get 25. We square this and get 3, and 25 times 3 is 75. This is 36. So this side adds up to 111. Since 100 is less than 111, this is an acute triangle. This is the longest side. 8 plus 8 is 16. 16 is less than 17. We cannot make a triangle out of this. First of all, we do know we have a triangle because this is the longest side, and 9 plus 12 is 21, which is bigger than that. So then we'll take the 15 and we'll compare it with the sum of the other two sides. So 9 squared plus 12 squared. This is 225. This is 81. This is 144. This adds up to 225. Since they're equal, we know that this is a right triangle. Okay, to figure out ABC, we need to know all the sides. So let's start by finding this right here. Now, this is a right triangle. This is like a 3, 4, 5, but just doubled up. So double 3 is 6, double 4 is 8, double 5 is 10. So I know without even using Pythagorean's theorem that right there is 6, which tells me that the entire side is 15 plus 6 or 21. Now, when we're doing, if you forgot the 3, 4, 5, you could have just used Pythagorean's theorem. This squared plus this squared is this squared, and you'd solve and get 6. Now on this, we'll call this, say, side X. So we have a right triangle here. So 15 squared plus 8 squared is equal to X squared. 225 plus 64 is equal to X squared. This adds up to 289. So X is the square root of 289, which is 17. So now we know that that side is 17. Okay. The longest side, we're going to compare that with the squares, the sum of the squares of the two shorter sides. So we'll say 21 squared, 17 squared, and 10 squared. I'm going to grab a calculator, and 21 squared is 441. 17 squared is 289. Let me just double check that. Yep. And 10 squared is 100. So 441, this adds up to 389. This is greater than, so we have an obtuse triangle. A square is a diagonal of 10. So if we drew a square, and then we drew the diagonal, we know that this is a right angle and that these are the same. And if this right angle is 10, well, we can call this x. And what we know is that x times root 2 is equal to 10. So x must be 5 root 2. You can just do that in your head, or you can simply divide each side by root 2. And you'd get x is equal to, now I'm going to multiply top and bottom by root 2 here. And we'll get 10 root 2 over 2, which is 5 root 2. I think that was probably pretty simple to have done in your head though. Anyway, one of the four sides is 5 root 2, and we know they're all the same. So the entire rectangle is a perimeter of 4 times the 5 root 2, which adds up to 20 root 2. the perimeter of an equilateral triangle is 18. So let's draw this. We have an equilateral triangle that looks like this. And each side is 6 if the entire thing is going to be 18. So this is going to be 6. And then if we draw an altitude, we know that this is a 60 because an equilateral triangle, all 3 angles are 60. So if this is 60, then we have a 30, 60, 90 triangle. That means that this portion right here, from here to here, is the short side, which is half the hypotenuse, which is 3. And the long leg is this times root 3, which is 3 root 3. And that is the altitude. So this is 3 root 3. If these are the two sides, the smallest the sides can be, the third side can be, is the difference between these, which is 5. The largest it can be is the sum of those two sides, which is 19. And it can be anywhere in between that. So we write that like this. In other words, x is somewhere in between 5 and 13, but not including 5 or 19, excuse me. Okay, the median BD. So we know we're coming from B, and we're going to this side right here. So we're going to find a spot halfway in between, which is right about there, and we'll call that point D. And we have to show that that's the median point by doing that. And then we're going to draw our line, which is the actual median, from there to there. Okay, the perpendicular bisector of CA. First of all, we need to know halfway in between, so we'll do a dot again and showing that that's the midpoint. We do that. And then we need to draw a right angle line through that point, so like this. Now, a couple of things. You need arrows on either side of this, and then you need to do this to show that that's perpendicular. That has to be there. Okay, the altitude CD. So we're coming from here and we're hitting this. We have to hit it at a right angle. So I'll just draw it, and I'll kind of guesstimate where the right angle would be. So something like this. But now I have to label this point D, and I have to do this to show that it's perpendicular. And that's the altitude. The altitude BD is this hitting the opposite side, but it has to hit at a right angle, and it can't do that inside of the triangle. It has to do that outside of the triangle. So the first thing I'm going to do is I'm going to extend this with a dotted line. And then I'm going to draw my altitude from here, hitting that line at a right angle. Like this. And a couple of things. I need to label this point D, and I need to put that there to show that that's a right angle. So there's the altitude BD. All right, the first thing I'm going to do is graph this. Negative 8, 1 is that point right there. Positive 4, 9 is this point right here. And 2, negative 7 is that point right there. And we'll call this A, B, C, and then we're going to connect those lines or those dots. Okay, and that's graphing that. Now the median CD, we're going to come off of here and we're going to go to some point like that, but I need to know for sure that that's the midpoint. So I'm going to do this mathematically. So I'm going to find the midpoint of AB. The x value of the midpoint is the sum of the x's, negative 8 plus 4, divided by 2, which is negative 2. The y value of the midpoint is the sum of the y's, 1 plus 9, over 2, which is 5. So the midpoint is negative 2, 5, which is in fact the point right there. So I'm going to call that point D, and then we'll draw a line from there to C, and that's the median. But we need to show that that's the midpoint. You have to have this right like that and like that, showing that that's the point D is the midpoint of those. For the altitude of AE, so we're going to come from A and we're going to hit the opposite side at a right angle. So that means that I need to know the slope of BC. So let's do that. The slope of BC is y2 minus y1, negative 7 minus 9, over x2 minus x1, 2 minus 4, which gives me negative 16 over negative 2, which is a positive 8. So the slope of the perpendicular is the opposite reciprocal. So starting from this point right here, I'm going to go down 1 and run 8, and I'll hit the origin. And then I'm going to draw a line from A through that point to the other side, like that. And I'll draw a dot there, and I have to label that point E. And a couple of things now. I have to make sure I show that that's a right angle by doing that. And that's that. All right, to find the perpendicular bisector of AC, we first need to know what the midpoint is. It looks like it's right there, but let's show that. So the midpoint of AC, the x value of the midpoint is the sum of the x's, negative 8 plus 2, over 2, which is negative 3. The y value of the midpoint is the sum of the y's, 1 plus negative 7, negative 6 over 2, which is also negative 3. So the midpoint is negative 3, negative 3, which is, let's see, 1, 2, 3, 1, 2, 3, that point right there. Now we need to come off at a right angle perpendicular to that. So we need to know the slope of this. The slope of AC is the difference of the y's, y2 minus y1, negative 7 minus 1, over x2 minus x1, 2 minus negative 8. This is negative 8 over 10, which is negative 4/5. That tells us that the perpendicular is the opposite, so it's positive, reciprocal, so 5 over 4. So starting from this point, we're going to rise 5, 1, 2, 3, 4, 5, and we're going to run 4, 1, 2, 3, 4, and we get to right here. So now we're going to grab a ruler and draw a line through those 2 points. And a couple of things that we have to do. First, we have to put arrows on either side because perpendicular bisectors need arrows. And then we have to show that this is equal to this. We've already used a single hashtag, so I'll use a double now. And we need to show that it's a perpendicular, so that has to show a right angle. And that's everything. Okay, let's start first by graphing this. So 3, 8, 3 to the right and 8 up is right here. That's point A. 5, 6, 5 to the right and 6 down is right here. That's point B. And negative 3 to the left and 2 up is right there. So I'm going to label this A, B, and C. Notice I didn't label it till after I knew where all 3 points were, so I didn't have to make my line go through a point. All right, so connect that. Connect this. And connect this. Okay. The median AD, well, it's coming from A and it's got to hit the midpoint of this. So I need to know the midpoint of BC. So the midpoint of BC. The x value of the midpoint is the sum of the x's, 5 plus negative 3, over 2, which is 1. The x value, the y value of the midpoint is the sum of the y's, negative 6 plus 2, negative 2. So the midpoint is 1, negative 2, which is right here. And then I'm going to label that point D because it's AD. This is point D. And I'll draw a point from A to that point. And we need to show that that's the midpoint, but you need these markings. That has to go there like that. And that's it. The altitude BE. So we're going to come from here and hit this at a right angle. So we need to know the slope of this. So let's do that. The slope of AC is the difference of the y's, y2 minus y1, so 2 minus 8, over x2 minus x1, so negative 3 minus 3, which is negative 6 over negative 6, which is positive 1. That tells us the slope of the perpendicular is the opposite reciprocal, which is negative 1. So, starting from this here, starting from this here, we're going to go to negative 1. So we're going to go down 1 and run 1. So that's the point right there. And we're going to draw a line, and it's actually on BC. So here's our line from B to there. And we have to do this. We have to put a right angle marking here to show that that's perpendicular. The perpendicular bisector of AB. So first of all, we need the midpoint of AB. So let's start there. The midpoint of AB, the x value of the midpoint is the sum of the x's, 3 plus 5 over 2, which is 8 over 2, which is 4. The y value of the midpoint is the sum of the y's, 8 plus negative 6 over 2, which is 1. So 4, 1 is the midpoint, and that's the point right there. Now the perpendicular bisector is going to go through that point perpendicular to this. So now I need to know the slope of AB. The slope of AB is the difference of the y's, y2 minus y1, negative 6 minus 8, over the difference of the x's, x2 minus x1, so 5 minus 3. This gives negative 14 over 2, which is negative 7. So we know that the perpendicular, the slope of the perpendicular is the opposite reciprocal. So if this is going to be a positive 1 over 7. So starting from this point right here, I can't rise 1 and go 7 because I'll go off the graph. So I'm going to do the opposite for both. I'll go down 1 and go to the left 7. 1, 2, 3, 4, 5, 6, 7, which is right there. Okay, and then I'm going to draw a line through those 2 points. Now, a couple of things. I need to put arrows on either side of it. And I've already used a single hashtag marking here, so I'm going to use a double hashtag marking there to show that that's the midpoint. And I need a right, oops, what did I just do? I need a right angle marking right here to show that it's perpendicular. And that's it. Okay, first thing we're going to do is we always graph it. So negative 7, negative 3 is 7 to the left and 3 down. That's point A. 5, 3 is 5 to the right and 3 up. That's point B. And C is 9 to the right and 5 down. 1, 2, 3, 4, 5 right there. That's point C. So let me label these. This was A, B, and C. And then I'm going to grab my ruler and connect those points. Now, in order to show that it's a right triangle, I need to show that two sides are perpendicular to each other. So it's obviously going to be this side and this side if it's anything. So I'm going to find the slope of AB and the slope of BC. The slope of AB is the difference of the A and B, y2 minus y1, which is 3 minus negative 3, over x2 minus x1, 5 minus negative 7. So this is 6 over 12, which is 1/2. Now we're going to find the slope of BC. y2 minus y1 is negative 5 minus 3 over x2 minus x1, 9 minus 5. This is negative 8 over positive 4, which reduces to a negative 2. These are opposite reciprocals. So therefore, we know that AB is perpendicular to BC. Therefore, triangle ABC is a right triangle. Okay, we always start by graphing. So negative 4 is 4 to the left and 4 down, 2, 3, 4, which is right there. And B is 4 to the left and 2 up. That's right there. That's point A, that's point B. C is 3 to the right and 5 up, which is right there. That's C. And D is 3 to the right and 7 down, which is right there. That's D. And then I'm going to connect those dots. Okay. Now, we want to show that the legs, not the bases, the legs are these. We want to show that the legs are congruent. So we want to see that AD is the same length as BC. So let's find the length of AD. AD is equal to the square. Now the distance formula is the difference of the x's, 3 minus negative 4 squared, plus the difference of the y's, negative 7 minus negative 4 squared. This is 7 squared, which is 49. This is negative 3 squared, which is positive 9. So this is the square root of 58. Now let's find BC. The distance formula for BC is the square root of the difference of the x's, which is 3 minus negative 4 squared, plus the difference of the y's, 5 minus 2 squared, which is, this is 7 squared, which is 49. This is 3 squared, which is 9. And so this is also the square root of 58. So these are the same length. So AD is congruent to BC. And actually that's all they're asking us to prove. And so we've proved that. Okay, these are always, sometimes, never problems. So a square is a kite. Well, to go from a kite downward, it's an always. So a square is always going to be a kite. In other words, everything below has all the properties of everything above. Number 18, a trapezoid is a rhombus. A trapezoid has no downward pathway to get to a rhombus, so this would be never. Number 19, a quadrilateral is a rectangle. To get from a quadrilateral to a rectangle, we have a direct downward path, so that's always. Number 20, the diagonals of a kite are congruent. This is sometimes because in a rectangle, the diagonals are going to be congruent. And so when we go upward, this is always a sometimes. So in other words, a kite's diagonals are congruent when it's a square, but that's only sometimes. The diagonals of an isosceles trapezoid are congruent. That's actually just one of the properties, so you don't need to think too much about that. That's always. Okay, both pairs of opposite angles of a rhombus are congruent. Well, this is congruent with this, and this is always congruent with this. So both pairs of opposite angles are always congruent. That's always. A parallelogram has consecutive angles, consecutive meaning next to each other. And those are always going to be, not always, those are always supplementary. They can be complementary. I take it back. They cannot be complementary. They're always supplementary, but they're never going to be complementary. In other words, this plus this can never add up to just 90. So this is never. A square is a regular shape. So all squares are similar, that's always true. A hexagon is a regular shape, so all hexagons are regular or similar. That's also true, always. Diagonals are congruent. If we look at a rectangle, the diagonals are congruent. So it's true for a rectangle, and that obviously means that it's also true for a square, because we're going downwards from that. And then finally, if we look at an isosceles trapezoid, the diagonals are congruent. So that's true for that as well. Both pairs of opposite angles are congruent. So if we look at a parallelogram, one of the properties is that both pairs of opposite angles are congruent. So we know it's true for a parallelogram, which then makes it true for a rhombus, a rectangle, and a square. A rhombus is not on here, but a rectangle and a square is. It's not true for a kite because although one pair of opposite angles are congruent, the other are not. So it's just those. Diagonals are perpendicular. Well, that's one of the properties of a kite. So we know that's true for a kite, and then that makes it true for a rhombus and a square. A rhombus is not on here, but a square is. And that's all we know is for sure where the diagonals are perpendicular. Okay, both pairs of opposite angles are supplementary, meaning they add up to 180. Well, that's going to be true in a square and a rectangle because 90 plus 90 is 180. So that's obvious. In a square and a rectangle. That's also true with an isosceles triangle. This angle and this angle are going to add up to 180 because consecutive angles do. So if this angle and this angle add up to 180, and then we know that those two angles are the same, it's also true that opposite angles are going to be supplementary. And that's it. Figure has at least one pair of congruent sides. Well, that's true for a kite because that's a pair of congruent sides. So that's true for everything below that. It's true for a parallelogram because this side is congruent with this side and so on and so forth. So it's true for all of those. And it's also true for an isosceles trapezoid because this pair of sides are going to be congruent. So it's true for all of these. Just that. All interior angles add up to 360. We don't need a hierarchy chart for this. These are all quadrilaterals, and all quadrilaterals, the angles, interior angles always add up to 360. So this is true for all of them. Diagonals bisect at least one pair of opposite angles. So this diagonal, this diagonal is going to bisect this and this. So that's true for a kite. That's not bisecting those, but it just says at least one. So that's true for a kite. And then it's going to be true for everything below the kite. Rhombus is not on here, but a square is. So we know it's true for a kite and a square. It's actually not true for any of the other things on here. So just those two. And that's it.